Hello viewers, welcome to the demo of Brain Control Rover as presented by me, Santosh Desai, on behalf of my team members here in BITS Pilani. In this demo, we shall look at the hardware first before jumping into design and architecture. Then, finally, we shall see the working of the rover in one of the successful test trials. Hello again. Apart from the robot chassis as viewed in the video, the functional components and controllers include an Arduino, a breadboard, a couple of L29 3D motor driver chips, an HC05 Bluetooth module, a couple of HC-SR04 ultrasonic sensors, a battery of 12 volts, a battery of 9 volts, a few jumper wires as necessary. It can be male to male, male to female as per the connections. Let's start with the Arduino and the breadboard. Arduino is a microcontroller used by robotic enthusiasts across the globe. A breadboard, as we all know it, is a component to prototype our circuitry. Now that we have the obvious out of our way, let's have a look at the HC05 Bluetooth module. The HC05 Bluetooth module is a pluggable serial port protocol module designed to add two-way wireless functionality to the project. As shown in the image here, there are a total of 6 pins for HC05 Bluetooth module. In our project, however, we use 4 of them. The VCC, the ground, the transmit and the receive pins are of interest to us. Remember that the transmit pin is connected to the receiver input of the Arduino board and vice versa, as shown in the pin diagram here. Next, let us focus on the HC-SR04 ultrasonic sensor. The ultrasonic sensor triggers an ultrasonic wave for a few microseconds and then listens for an echo after the transmission. This will help us to get the distance from any obstacle in the direct path of the movement of the rover. We have installed 2 of them, one in the front of the rover and another at the back of the rover. The pins of the sensor are shown here. It consists of the standard VCC and ground for power supply. It also consists of programmable trigger and echo pins to be connected into the data pins of Arduino. The L29 3D motor driver chip, as the name suggests, controls the motors behind the wheels. Each L29 3D chip can be used to control 2 motors. 2 pins on the either side of the chip connect to the motors. The direction of current translates into the direction of the motion of the wheels. This can be programmed by 4 data pins provided by the chip to control the 2 motors connected to it. Our robotic chassis consists of 4 wheels, hence we shall need 2 L29 3D chips. Now let's look at the power distribution. We shall use a 9V battery to power the Arduino. The Bluetooth module derives 3.3 volts of input supply from the Arduino. Similarly, the ultrasonic sensor derives its 5V supply from the Arduino. The motor drivers are responsible to control the power flow to the motors. They feed on the input from the 12V battery. The final result of the connections described so far results in this prototype as displayed on the screen. In this picture, you can see both ultrasonic sensors plugged in on either side of the rover. On the left, you can see the battery setup powering the wheels. The L29 3D chip can be seen right in the middle of the breadboard. This is the back view of the rover. We can clearly see the ultrasonic sensor of the rear end here. This is the front view of the rover. The Bluetooth module is lying on top of the Arduino board. The 9V battery located under the roof of the rover along with the motors powers the Arduino as mentioned earlier. This is the top view of the rover. As you can see, the connections are polarized very densely near the L29 3D chips. Now let's come over to the brain part of the project. One of the major questions that pops up every now and then is that, is it really possible to control an object just from the thoughts? Well, a thought is scientifically indescribable as a quantifiable input that can be repeatedly reproduced as is. However, there is a workaround. We can use the EEG signals that are known to correspond with specific brain activity, and then we can train ourselves to produce the required patterns. In this way, we may hope to produce some quantifiable input to any processing unit. What we have just described is the very intuition behind brain control interface. Now, to harness the EEG signals effectively, we have several custom EEG electrode kits. For this project, we have used the Emotive Epoch Plus kit. It provides an interface to read and understand the user's brain activity in real time. For the analysis part of EEG signals, we have purchased the Pro license from their official website. It has helped us a lot in training users and understanding the brain activity. During experimentation and testing, we needed an object to focus over. Gladly, Emotive provides an interface to control a cube virtually. This explains how focused we are. Repetitions of this training helps the users to understand themselves in terms of actionable thoughts. The mental command interface provided by the Emotive is sufficient to train simple movements such as that of a rover, in this case forward and backward. Okay, that's enough of the theory. Let's have a demo now. In this demo, I'm blinking my eyes, which is an actionable thought to move the rover backward. To move the rover forward, however, I'm thinking of a song. Notice that thinking of a song is a passive thought. As you can see, actionable thoughts are easily identified when a similar amount of training is given as compared to the passive thoughts. I'd like to thank my teammates for their incredible hard work and patience during this tedious task. I'd also like to thank Professor Vinay Chamola and Professor Vandana Agarwal for their guidance and insight on various topics. It would have been a Herculean task to finish this project without knowledge and insights flowing from different directions. It is the combined expertise of the entire team and the professors that we were able to finish this project in time. Finally, I'd like to thank you, dear viewer, for expressing interest in our project. Hope you